सर कहाँ गए?
गुड इवनिंग। कहाँ थे हम लोग? कहाँ पहुंचे थे? याद है किसी को? फ्रेम ऑफ रेफरेंस। फ्रेम ऑफ रेफरेंस हो गया ना? सो third definition is that of position vector. अरे कुछ बोल ही नहीं रहा तो कहाँ से ऑडिबल हो जाऊंगा? मतलब रुक जा 2 मिनट। हाँ, so the position vector is as we, so this is not new. Okay, this we have seen before, and it does not have any sort of any complications about it. Very simple object. So a vector drawn from the origin of the frame to the position of the particle. Right, this is called the position vector. This is sometimes also called the radius vector. Very rarely now, but some time back इसका जो है इसका जो नाम है वो पोजीशन वेक्टर नहीं, मैक्सिमम लोग इसको रेडियस वेक्टर बोलते थे. Therefore, the symbol is R, and of course the units will be the units of length, right? So meters, kilometers, parsecs, whatever. Next is the displacement vector, right? Again, we have seen this. So this is a vector drawn from the initial position to the final position of the particle. Now, what do we mean by initial and final? So there is no definition as such of initial and final. It is your choice, right? And I think we have discussed this before. Initial would mean t is equal to 0, but this would not mean that time is beginning or it is the beginning of time. Let me put it like this. T is equal to 0 means that you have started your stopwatch, and t is equal to t is the final position where you have stopped your stopwatch. This does not mean that the motion before your starting of the stopwatch is not there, and the motion of the particle after you stop your stopwatch is not there. It is there, and it can be calculated also. To calculate the motion or to predict the motion or to tell the motion before the stopwatch was started, if you know position vector as a function of time, then you will put in t is equal to negative number, right? And of course, you want to find what happens after a particular time, then you have to put in that value of time. So why do we need two? So here the symbol is D. Well, actually the symbol is not D. The symbol is something else. You've seen this before. It is S, and the units are the units of length. Right now, why do we need two units or two objects having units of length? To specify the motion of the particle, right? So the thing is that so the thing is that ये number 4 है ये, right? This is number 4. You have to write the number 4. Yeah. So the thing is that when we look at the particle from different frames of reference, like we discussed in the last class, we get a different perspective or a different interpretation of motion. That is, that two observers from two frames of reference which are different may observe completely different types of motion, right? So what happens is that if this is our frame of reference, let's say S1, right? And we have a particle which is at a coordinate of Ri, and after some time, same particle is at coordinates Rf, then the displacement vector of the particle is this. Now, if I were to look at this problem from another frame of reference, let's say S2, then the initial position vector of the particle would be this. Let me call this Ri dash. And the final position vector of the particle would be this. Let me call this Rf dash. But the displacement vector would be same, right? So from two different frames of reference, it turns out that the displacement is always the same. Okay, frame of reference का कोई unit नहीं होता. It turns out that the displacement vector is the same. Okay. So from two different frames of reference, the displacement vector would be same, right? The displacement vector would be different from two different frames of reference if they are moving with respect to each other. But for the moment, we are not really considering that. We are simply considering frames of reference which are stationary with respect to each other. Right? So from two frames, S1 and S2, the position vector, right? I'm going to use PV for short. Position vector may be different but displacement vector will be same. Okay, right? So this is why we need two different vectors having the same units to describe the motion of a particle, right? Please remember this. Position vector is something which the particle has at an instance of time. Okay? In another instance of time, the position vector of the particle may or may not be different. The displacement vector is a vector which develops over an interval of time, right? So if there is displacement, there must be an interval of time, right? So let me just write this down also. So position vectors are defined at one moment in time, whereas the displacement vector is a vector over an interval of time. राइट तो अगर एक पार्टिकल का नॉन जीरो डिस्प्लेसमेंट वेक्टर है तो इसका मतलब कि वो पार्टिकल का जो भी मोशन हुआ है दैट मस्ट हैव अकर्ड ओवर ए नॉन जीरो इंटरवल ऑफ टाइम. मतलब कि कुछ ना कुछ इनिशियल रहा होगा टाइम का वैल्यू, कुछ ना कुछ फाइनल रहा होगा टाइम का वैल्यू. छोटा है बड़ा है टाइम का वैल्यू, टाइम का इंटरवल वो हमें नहीं मालूम है, बट नॉन जीरो है ये डेफिनेट. नेक्स्ट, number 5, I think. So number 5 is the distance traveled. हाँ, एक मिनट रुको. So what do we mean by the distance traveled? So there are three ways of looking at the motion of an object, the motion of a particle. The first way is that you describe the macroscopic property of the particle. Right? That means that particle का एक initial position था और एक final position है. बीच में उस पार्टिकल ने क्या किया ये मुझे कोई मतलब नहीं. ठीक है ना? तो पार्टिकल का इनिशियल मोमेंट इन टाइम पे पोजीशन क्या था, फाइनल मोमेंट इन टाइम पे पोजीशन क्या है, ये दो पीसेस ऑफ इंफॉर्मेशन है मेरे पास, लेकिन बीच में क्या हुआ ये मुझे मालूम नहीं. सो दिस इज द मैक्रोस्कोपिक व्यू. आप इंस्टीट्यूट से निकले और घर पहुंचे, राइट? सो your parents would be interested in the time that you have left the institute and the time that you have arrived at home, right? Okay. So normally they are not going to ask you कि नहीं रास्ता कौन सा लिया. रास्ता आपने हो सकता है कभी आपने एक रास्ता लिया, कभी आपने दूसरा रास्ता लिया, you know. So the paths that you follow, the way that you go is immaterial, is not required. We are just looking at the initial and final positions. The second perspective is that we address the details of the motion. We don't leave out any detail. What does this mean? So when we look at motion from the second perspective, we will find that we are looking at every instance of motion, right? So it would be like you are going from your school or from the institute to your home, and your parents are, you know, they're calling you every second. Ab kahan pahuncha? Ab kahan pahuncha? Ab kahan pahuncha? So every instant we are looking at, that is the second perspective, which we'll see abhi thodi der mein. The third perspective is slightly different. We are not looking at each and every instance. We are not looking at only the initial and final points. We are looking at a macroscopic view. हम ऊपर से देख रहे हैं, मतलब हम एक ओवरऑल पिक्चर चाहते हैं, हम डिटेल नहीं चाहते हैं, लेकिन हम जो डिटेल्ड मोशन हुआ है, although we don't want that detail, but still we want more information as compared to मेरे को बस इनिशियल और फाइनल पॉइंट बता दो, बट लेस इंफॉर्मेशन एज कंपेयर्ड टू मेरे को हर एक इंस्टेंस का डिस्क्रिप्शन दो, right? So it would be like your parents are calling you every 10 minutes or so. अच्छा भाई अब कहाँ पहुँचे बता दो भाई, कितनी देर लगेगी बता दो भाई. So three perspectives of motion. One, you look at only the initial and final points. You're not bothered बीच में क्या हुआ. Two, you are looking at every point of motion. You are looking at every point the particle passes. Okay? You are looking at extreme details of the motion. And number three is somewhere in between. You are looking for some information which is greater than initial and final point, yet less than a description of every moment of motion. And distance traveled is the third wala bit. So if we have a particle which is moving from this initial position to this final position, then the particle may have moved like this. Okay. The displacement vector would be only this. The displacement vector would not be bothered with the complexity of the motion itself. It is only bothered with the initial and final position. The things that we are going to learn in 6, 7, 8, that will be bothered with the instantaneous, with the detailed description of what has happened. But distance is somewhere in between. So it does not ask, or it does not tell you as less information as initial final point. It does not tell you each and everything about the motion, right? It tells you something more than initial final points and something less than a detailed description, right? So the distance traveled is the length of path traversed by the particle. It is having a symbol which is really nothing. I mean, so कोई official symbol नहीं होता है, सीधा D लिख दे रहा हूँ. And the units are the units of length. नहीं, S is for displacement. S is not for distance traveled. Right? अभी हम आते हैं, वापस आते हैं distance traveled और displacement में भी. So first let's try this. How? Can scalar quantities ever be negative? Well, yes, they can. Okay. Yes, they can. But distance can never be negative. Temperature can be negative. Temperature is a scalar quantity, right? Minus एक second, 1 minute. So, uh, here, so we'll talk about the magnitude of distance and magnitude of displacement and the relation with distance in a moment. But first, let me just give you a question on distance. So, a particle travels such that it's uh, such that its x and y coordinates are given by x is equal to 5 sine pi t, y is equal to 5 cosine pi t meters. T is in seconds, of course. Find distance traveled in 2 seconds. हाँ हाँ, यही हूँ मैं। ये कैप्स में क्यों लिख रहा है भाई? लग रहा है चिल्ला रहा है। हाँ, मैं भी मॉडर्न हो गया हूँ। नहीं नहीं, मैं बोल रहा हूँ मैं मॉडर्न, मेरे को कोई फर्क नहीं पड़ता है। लेकिन सही में कैप्स देखने पे लगता है कि चिल्ला रहा है कोई। हाँ, क्या है बताओ? डिस्टेंस आया? डिड यू फाइंड द डिस्टेंस? है ना? 20 मीटर्स। कैसे निकाला भाई, ये तो बताओ। नहीं, 20 मीटर्स आंसर नहीं। 10। तुक्का नहीं मारना है। 10, 25, क्या मतलब 5 के मल्टीपल में ही चलेंगे क्या, क्योंकि वहां पे 5 दिया हुआ है। नहीं नहीं नहीं, 10 नहीं है। अरे नहीं भाई, 5 के मल्टीपल नहीं है। अच्छा, मतलब 5 का मल्टीपल नहीं तो 18। अच्छा, इवन नंबर भी नहीं है, चलो। कोई पहले नोट्स नहीं पढ़ता है ना? प्रतीक्षा, तुमने नोट्स पढ़ा हुआ है ना पूरा? तुलिका, नोट्स नहीं पढ़ा क्या पहले से? इसका मैं। ओ। ओ हो। मैंने ही नहीं भेजा है, ओहो। हाँ हाँ, रुको ना, दिनेश सर ने मुझे आज ही भेजा है, मैं क्या करूँ? मेरे पास तो सब वो था, अलग अलग पन्नों पे था। मैंने किसको भेजा था? मैंने प्रतीक्षा को भेजा था और और को भेजा था। Z11 Batch 2, यही है ना? ये गया। ओ देखो, पहले पहले पेज देखो, पहले फोटो है वो, मैंने डाला था, आई रिमेम्बर दिस। So if you open the lecture notes, you will find in the first page the motion of the motion of the planets with a moving sun. A wonderful photograph, visualization, not a photograph. Yeah. So whatever. Yeah. If you go to page 3 of the notes, there it is. Yeah. If you go to page 3, then I've talked about distance. Yeah, and I have put in some questions into the lectures. So we will be discussing these questions in the lecture itself, right? So it would be very nice if you could just read the lecture, and if you could, do the problems before coming to the lecture. लेक्चर में हम फिर से डिस्कस करेंगे यही चीजें। और मैंने सारे क्वेश्चंस की आंसर की भी डाली हुई है, ताकि आपको प्रॉब्लम ना हो। हाँ, सो आई पुट इन एवरीथिंग। चलो हाँ भाई चलो, तो आई विल शो यू हाउ टू डू दिस. Thing which is simple like distance, or at least seems simple like distance, is actually a very complicated thing. So if a particle is supposing moving along such a path and we wish to calculate the length of path, right, then I hope that you are at least getting the vibe that somewhere calculus is lurking around if you want to find the length of the blue line. So in calculus, I talked about finding the slope of the curve, right? And I talked about finding the area under the curve, but I did not talk about finding the length of a curve, which I will discuss here. So as we did in calculus, the first step must be to isolate a minute part of the curve. Right? That must be the first step. Okay. So what I do is I consider this portion of the curve, and this portion of the curve looks like a, and this portion of the curve, nahi, one nahi hai beta, and this portion of the curve looks like a straight line, right? And I want to find the length of this straight line. Okay, so to find the length of the straight line, what I do is that I construct a teeny tiny right angle triangle where this side of the right angle triangle is dx and this side of the right angle triangle is dy, right? Therefore, what do you think the hypotenuse is going to be? अगर साइड एक dy है एक dx है तो यहाँ पे आएगा अंडर रूट ऑफ dy स्क्वायर प्लस dx स्क्वायर. Now you may stop here and think कि एक मिनट dx और dy तो इतने छोटे हैं कि dx स्क्वायर और dy स्क्वायर तो जीरो हो जाएगा, and you would be correct in a way but you would be incorrect in another way. If you were to take this as zero, nobody can stop you, but this would not give you the length of the curve. You would end up with the conclusion that ये जो small portion of the curve मैंने लिया है इसका length ही zero है तो काम खत्म हो गया, फिर सब कुछ zero है. But we will not take this as zero. We will say that this is the infinitesimally small length of the curve dl. Okay. And the total length of the curve is equal to integration of dl, because after all integration means summation, and if I am summing up all the little dl's that make up this curve, then I am arriving at the length of the curve. And since I am dealing with dl, therefore I am guaranteed that this straight line would be, or this collection of straight lines would be a perfect fit for the curve. So integration of dl, the integration of dx का मतलब होता है area, integration of y dx का मतलब होता है area under the curve. ये integration of dl है, तो इंटीग्रेशन ऑफ डीएल का मतलब होता है summation of dl, right? So let me उल्टा लिखने दो मेरे को. So summation of dl, which is the integration of dl. So integration of dl would mean integration of under root of dx square plus dy square, right? Now what I can do is I'll be very clever here, and what I'll do is that I'll take out dx common, and if I take out dx common, I end up with 1 plus dy by dx whole square. Okay, so length of the curve is equal to integration of under root of 1 plus dy by dx whole square dx. Is this okay? Is this understood? I'll go back to the previous slide. Okay. Chalo. So let's solve this question then. Please notice the mathematical steps that I'm taking. X is equal to 5 sine pi t. Therefore, dx by dt is equal to 5 pi cosine pi t. Right? Y is equal to 5 cosine pi t. Therefore, dy by dt is equal to minus 5 pi sine pi t. Okay, now please notice the next step. This is very, very important. Dy by dt upon dx by dt. So I'm basically dividing the two expressions. When I divide the two expressions, on the left hand side, I'm getting dy by dt divided by dx by dt. And remember, I told you that dy by dt or dy by dx, it behaves like a fraction, where dy is the numerator, dx is the denominator. So, dt and dt will cancel out, and I will get dy by dx. And this will be equal to minus 5 pi sine pi t upon 5 pi cosine pi t. And we get minus tan pi t. Okay? Okay? Now I am going to change the slide once again. So length, which is equal to integral of root of 1 plus dy by dx whole square dx will be equal to integral of root of 1 plus tan square pi t, राइट। dy by dx की वैल्यू मैंने डाली यहाँ पे, मैंने यहाँ पे dy by dx की वैल्यू डाली, dy by dx की वैल्यू ये रही, और dx की वैल्यू क्या है, dx की वैल्यू तो यहां से आ रही है। अगर dx by dt 5 पाई कोसाइन पाई t है तो श्योरली dx must be 5 pi cosine pi t dt. Hope everybody is following this. So here I will get 5 pi cosine pi t dt. Right? I'll write it properly. Integral of 1 plus tan square pi t into 5 pi cosine pi t dt is equal to, ये क्या है भाई, ये क्या है, ये क्या चीज है, ये 1 प्लस tan स्क्वायर, हाँ सेक है ना, हाँ अभी मैं एक्सप्लेन कर रहा हूँ। सेक इंटू कोसाइन क्या हो जाएगा, सेक इंटू कोसाइन क्या हो जाएगा, 5 पाई बाहर आ जाएगा, इंटीग्रल dt बचेगा सर। लिमिट्स हैं 0 to 2, दिस इज 5 पाई इंटू 2, 10 पाई मीटर्स। हाँ बताओ क्या नहीं समझ में आया, क्या बोल रहा था, ये dx कहाँ से आया, dx upon dt is something, therefore dx must be this something into dt, right? फ्रैक्शन है ना, क्रॉस मल्टीप्लाई कर सकते हैं ना, मेथड ऑफ सब्स्टिट्यूशन में तो क्रॉस मल्टीप्लाई किया ही था ना हमने, कोई ऐसा नहीं है कि मैंने कोई अननोन स्टेप उठा लिया है। और कौन सा स्टेप नहीं समझ में आया, आया सारा स्टेप समझ में, भाई लास्ट स्टेप में मेरे पास अंडर रूट 1 प्लस टैन स्क्वायर पाई टी, तो सेक पाई टी हो गया, सेक पाई टी इंटू कोसाइन पाई टी 1 हो गया, 5 पाई है, 5 पाई तो कांस्टेंट है, वो बाहर चला गया, तो बचा इंटीग्रल dt, और इंटीग्रल dt तो t होता है। दे रहा हूं ठीक है। Before I give the next question, I would like to ask, has anybody understood what happened here? Can you understand the significance of these two things? What is so special about these two things? What is so special about these two things? The displacement, we are not really bothered with displacement, but how you could have actually figured out the answer without doing any integration. x is equal to 5 sine pi t, y is equal to 5 cosine pi t. What is the value of x square plus y square? What is the value of x square plus y square? What is the value of x square plus y square? 5 nahi hai, it is 25. What is the significance of this equation? What is the significance of this equation? What is the significance of this equation? Yes, yes. 3, 4, 5 ट्रायंगल कहां से हो जाएगा? x square plus y square क्या होता है? X square plus y square is the square of the distance of a point from the origin. It is in fact the mod of xi cap plus yj cap. उसका square है, but ठीक है. X square plus y square is the distance of the point from the origin. So this represents a set of points which is always at a distance of 5 from the origin. What will these set of points look like? Set of points which is always at a distance of 5 from the origin. सर्कल का रेडियस क्या होएगा? 5. सरकमफ्रेंस कितना है सर्कल? सरकमफ्रेंस कितना है सर्कल? 10 pi. Yeah, you could have figured it out. But there is a gap in my logic. Can you tell me the gap between drawing the circle and telling the answer as 10 pi? What is the gap? There is a gap in the logic. जो डेटा मैंने यहाँ पे स्क्रीन पे लिखा हुआ है, yes, good. Yeah. We don't know if it covered a full circle in 2 seconds. Are you sure you don't know? Or do you know? 2 सेकेंड में क्या हो जाएगा? t का वैल्यू 2 रखेंगे तो क्या एंगल आ जाएगा साइन और कोसाइन में? t का वैल्यू 2 रखेंगे तो साइन और कोसाइन में क्या एंगल आ जाएगा? हाँ, आया समझ में? अभी चमका कुछ? You should, yeah, so you should approach the problem from all perspectives. Everything is connected. Everything is connected. सर्टी हो गया है तो अब ये फिर नेक्स्ट क्लास में कंटिन्यू करते हैं. Okay, we'll continue this in the next class. Please read lecture 1 of kinematics. If possible, try to complete the tutorials. Lecture 1 करना है ना? Lecture 1 करना है. I will be discussing lecture 1 once again in the next class. If you can finish, it will be very nice. And if you try to keep at least 3 lectures ahead of me, read the lectures, do the questions, right? Chalo, okay.